Welcome back to our second video, and we were finishing up the horizontal parabolas. So if we'll go back to our chart here, and we noted that if it opens to the left, then your distance to the focus is still p, but it's negative. And this directrix would be right here. That would be the directrix for that parabola. Let's make note about the p values. If I open to the right, then p is greater than 1, or greater than 0, I apologize. If it opens to the left, p is less than 0. Let's fill in some of our chart here. The vertex is still at the origin. The axis of symmetry now is the x-axis, so we have y equals 0. The focus is the distance p along the x-axis. So now the focus is whatever that distance p is and 0. And the directrix is a vertical line, so it's going to be x equals that distance of p, whether it's plus or minus. Now, just like with the vertical, we are going to shift the vertex. So now we have an h and a k. I do want to pause here and note something. You notice h is always, always, always with x. K is with y. Here, when we switch and go horizontal, the k remains with the y and the h remains with the x. The tendency here is for you all to see the first one and you always think that's h, but you need to pay attention to the one that's with the y. That's your k, and the one with the x is your h. All right, so if we have a parabola that's opening, let's say, over here to the right, all right, then you have this axis of symmetry, but if you notice, you have slipped over h and you've gone up k. So you still have your focus, which is inside. This is still going to be the distance p, and it's still going to be positive because it's opening to the right. Your directrix would be the same distance, but outside. That would be your directrix. So the vertex is then shifted by h and k, and your axis of symmetry is now a y equals whatever that k value is. Your focus is on that k line, but the h part, the x value, is shifting depending upon p. So here you have the h that's shifting by p, but it's always on that k line. And the directrix is a vertical line, just like it was up here, and it is shifting as well from the h, that distance of p. So this is a vertical line, x equals h plus or minus p. Now you can also draw one down here, and it could be up here. I'm just drawing it down here. If it went to the left, then this would have shifted a negative h. This would be a negative k. You would still have the focus would be somewhere inside. This p value would be a negative p. All right, your directrix would be, again, a vertical line outside. That would be the directrix. So you have the same components working on the left and the right if you have a horizontal parabola, but the vertex has been shifted. Let's just make note here. This has a positive p value. This has a negative p value because it's opening to the left. Let's do a couple examples knowing these components of the parabolas. So if I want you to find a standard form given that the focus is at negative 6, 2 and the vertex is at negative 6, 1, let's kind of get an idea of what this looks like. when you do these, I am not going to help you if you come up and say, I don't understand, unless you have drawn a picture. 1, 2, 3, 4, 5, 6, because it helps so much. -6, -1 is my vertex. If my focus is -6, 2, there's my focus. All I did was put 2 dots on the paper, and I know exactly that this is going up. I know what type of equation. I know that I have a positive p-value. I can see what the p-value is. You can pull so much information from the picture, which is why I want you to do that. So you can look at this and you can see that I went up 3. P is 3. You know you're going up because the vertex and the focus are oriented such, and you know the parabola is going to eat the focus. The focus is always inside. You know that you have a vertex here that has been shifted, so you have a new h and a k. So let's write this in our formula. We are going to use this formula because it's vertical, it's going up and down, and we know we have a positive p, so I'm going to leave that right there so you can see it. All right, so we know we have an h and we have a k. So this would be the equation of x, and then I'm going to subtract the h, which is -6 squared, equals 4 times my p-value, which is 3, and then I have y minus my h value, or k value, which is -1. I work that out and simplify that. I'm going to have x plus 6 squared equals 12 times y plus 1. That is your standard form of that equation. Now you'll get to the point where you look at that vertex, so you know immediately that these are going to, if these are both negative, these are both going to be positive. Check it. This is my h, that's with my x. This is my k, that's with my y. All right, let's try another one. If I give you the focus is -1, 5, I tell you the parabola opens to the right, and I'm asking you to find the equation if it contains this point. All right, this is not my vertex. It just contains that. So that's not an h and a k, that's an x and a y. All right, the vertex was h and k. This is just an x and a y on the parabola. Again, let's kind of get an idea of what's happening here. We sketch this out a little bit. I'm at -1, 5. So 1, 2, 3, 4, 5. And that's my focus. I know I open to the right, and it contains 8, -7. All right, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So I'm down here. That's just a point on this thing. All right, you know that it opens to the right. You know that this is your axis of symmetry. You know that the parabola, the vertex, is on this point. So somehow it's doing that, or maybe it's doing this, or maybe it's even closer. But you know that it's going through this point, and you know that the vertex is on this line. So we have a couple things working for us here. We don't know the p-value yet, but we do know the direction, which helps us a lot. So let's write down that part of the equation. I know I'm opening to the right, which tells me that I have a horizontal axis, which tells me that I'm going to be dealing with y minus k. Let's just write the equation. Equals 4p x minus h. Okay, I've got my h and my k in the right spot. And I know that I have an x and a y. I don't have my h and my k yet, sort of, and I definitely don't have the p. Let's talk about the vertex here. You know that the k for the vertex is 5. You don't know what the h value is for the vertex. So the vertex right now is at some value that's -1 right here, back minus the p value. See, I'm going to start here at -1, and if I go back, subtract p, I'm going to get to that h value, and then I know that I'm on that k line of 5. So this becomes my new h, and this becomes my k when I plug everything in here. And I don't know what p is. That's what I'm trying to find. Okay? So now I have an x and a y, and I have an h and a k. So let's plug all this in here. Let me grab a different color. So I have the y, which is -7, minus the k, which is 5, and I'm going to square that. I don't know what p is. I have x, which is 8, minus my h value, which is -1 minus p. That looks a little crazy, but we can figure this out. So -7 minus 5 is -12 squared is 144. I still have the 4p. All right, but I need to distribute this negative to these. So that gives me 8 minus a -1, which is really 9. And that negative is going to make that a positive p. Okay, now I'm going to, let me get a different color. Now I'm going to distribute here the 4p to both of those. All right, I still have the 144, but now I'm going to have 36p plus 4p squared. All right, I've got some big numbers here. I also recognize that everything can be divided by 4. So I think I'm going to do that right now. I'm going to divide everything by 4, and I'm going to set this equal to 0. So that I have 0 equals p squared plus 36 divided by 4 is 9. I'm going to bring the 144 over. That will give me a -36. That can be factored. So you have p, you're going to have p times p gives you p squared. I need factors of 36 that add and subtract to give me 9. 12 and 3. 12 needs to be positive, so I get a positive 9. Positive 12, -3 gives me my -36. That works. So this tells me if the product of these two is 0, then one of them has to be 0. So either p is -12 or p is 3. All right, well, I have to decide. If p is -12, that's going to open where? That opens to the left. That's not right. Okay, so here I know p is 3. Well, take that back up here to our vertex. So now my vertex, if p is 3, if I was at -1 minus 3, I'm going to be, oops, I shouldn't have put a parenthesis there, because I still have my 5. Poor 5. There we go. All right, so the vertex is really -4, 5. That's my h and my k that I've now established. So now I can write the equation. I'm going to go back up here. Ready? So you have y minus your k, which is 5, squared, equals 4 times your p, which is 3, and this is x minus your h, which is a -4. So I have y minus 5 squared equals 12 times x plus 4. All right, I would like to set up 2 more examples. All right, what I'd like you to write down, let me see if I can get this out of the way. These are the examples that we're going to do in class. So I'd like you to copy Example 3, set this up. Here's the last little part of the notes that I gave you, and we'll do this where we're calculating the tangent line to a parabola. See, the parabola's here, and we want to know the tangent line at this point P. So obviously I have to give you that point, like I did down here, and I want to know the equation of the tangent line to this parabola. So these two examples, 3 and 4, we will work in class. Please have the rest of the notes done, and I will see you then. Thank you.